In this video, we are going to create this really fun project using React and Tailwind, and it is going to be this Pokemon memory game. So let me explain how the game works. As you can see, we have 12 cards of Pokemon, and each time you click one, we change the order of the cards. So you need to remember which one you clicked before. Otherwise, if you click on the same card twice, you will lose the game. And in order to win the game, you need to reach the score of 12 because we have 12 Pokemon cards, and clicking on 12 different cards in a row means you never clicked on the same one twice, and in this way you will win the game. As you can see, I clicked on the same one twice and there is an alert that says game over. Also, we keep track of the best score, and each time you click on a card, we update the current score as well. If you're a beginner, this is going to be a really fun and good exercise for you. I will be explaining every single line of code, so let's get into it. So to start the project, here I have my empty React project with Tailwind inside. If you don't know how to create one, you can click on the card and watch this video where I create this responsive navigation bar using React and Tailwind. And at the beginning of that video, I explain how to create it from scratch. Or if you don't want to bother watching another video, there's going to be a link in the description that will lead you to official website of Tailwind where it explains it step by step. So let's start by making this empty div a background. Let's make it cover the entire page by setting it to minimum age screen. That means minimum height 100 VH. I will make this a flex container and change the flex direction to column because we are going to have two items inside. The first one is going to be a div that is going to have information like the game's title and the scores, and right under that we are going to have a grid that we will store the Pokemon cards that we will fetch. So I want the information div at the top and the cards at the bottom. So that is why I changed the flex direction to column. Let's center the items as well. Items center and justify center. Let's put some gap between those elements, gap 3. And for the smaller screens, it is going to be 5. For the background color, I will create a gradient. So gradient to right, from pink 500 via red 500 to yellow, and let's also give it a padding as well. So as I mentioned a second ago, we're gonna have another div inside that is going to have the game's title, Pokemon memory game, and right under this another div which is going to have the score and the best score. So let's make this one a flex container and change the flex direction as well. Center the items, center the text, and create a backdrop blur effect. Let's make the background color black, and I will lower down the opacity. So -70, give it a padding of 3, and for these smaller screens it is going to be P5. And for the H1, let's set the font to mono, increase the font weight, and increase the text size. Let's make the text white. And for the smaller screens, the text is going to be bigger. And for the medium screens, it is going to be 5XL. Let's also put some space at the bottom. So margin bottom 2. And for the smaller screens, it is going to be bigger, a padding of 2. And for the smaller screens, the padding is going to be 5. Also, this div that has these scores inside. So the grid that we are going to create for the Pokemon cards is going to be right under this. So let's give it a margin bottom of 3. And for these smaller screens, it is going to be bigger. Let's set the text color to white and increase the text size. For these smaller screens, it is going to be bigger. And for the medium screens, it is going to be 2XL. Also, let's give this container rounded corners. And that is it with the information div. Right under this div, we are going to create the container that we will have the Pokemon cards inside. So let's create a div with the class name grid. So because we are going to have 12 cards, this grid is going to be 4 by 3. But for the smaller screens, there is going to be only 2 columns. And for smaller screens, there is going to be 3. And for the larger screens, that is going to be 4. Also, let's put a gap between the cards. And for the smaller screens, the gap is going to be 4. Let's set the width to 100% and maximum width to 3XL. So in this way, we have a responsive grid, but right now we are going to leave this empty because we haven't fetched the data yet. So before we fetch the data, let's talk about how the game works and what we will need. So once we fetch the data, we need an array to store that data, and we also need to be constantly updating this array because each time you click on the cards, we need to shuffle the array, so change the position of the cards, and also keep track of what you clicked. And we also need to check if you click on the same card twice or if you're not. So that means we are going to create 4 state variables, and the first one is going to be an array that we will store the Pokemons that we will fetch. As you can see, my VS Code automatically imports useState. If this doesn't happen for you, just type this down. So this state variable is going to keep track of the Pokemons that we fetch. And the second one is going to be clicked Pokemon and set clicked Pokemon. And this is going to be taking an array as well. And this one is going to keep track of the Pokemons that you clicked. And we are going to be using this setter function to understand if you click on the same card twice and lose the game, or if you haven't and you continue the game. Also, we need to keep track of the scores as well. So we will need 2 more state variables. So one is going to keep track of the current score, and the other one is going to be keep track of the best score. And we have all these states we need. Let's go over this one more time if there's any confusions. So we are going to be using an API to fetch 12 Pokemons as a object, and we are going to be storing those objects inside this Pokemon array. And using the setter function, we are going to be constantly updating it. For example, once we are done fetching the data, we will use this set Pokemon function to put the data we fetched inside this array. And this second one is also an array. And this one is going to be basically responsible for the game's logic because it will help us to track which Pokemon cards you clicked on. We are going to use this setter function to update this clicked Pokemon array, and we will constantly check if there is matching IDs. So if there is any matching card, that means you click on the same card twice and you lose the game. Otherwise, we will keep checking. And these two are pretty straightforward. This is going to keep track of the current score. If you keep clicking on the different cards, we are going to be adding the current score plus 1. And this one is basically going to compare the current score to the best score. So if the current score reaches a higher one than the best score, using this setter function, we are going to update the best score. Right now they are set to 0, and these two are set to empty arrays. So now that we understand how they work, let's use them. First, we are going to fetch the data. Let's create a function named fetch Pokemon. This is going to be an async function. Inside, we are going to create an empty array called Pokemon list. So as I mentioned earlier, we need to fetch 12 Pokemons, and obviously we are not going to use fetch 12 times. We are going to use a for loop. Let's set a I variable to 1, and we are going to increase this unless it is smaller than 12. And inside this for block, we will use the fetch inside this response variable. And the API that we are going to use is called Poki API. You can find the link in the description to this website. Let's click on check out the docs. As you can see, this is a consumption only API. Only the HTTP GET method is available on resources. Let's scroll down. And this is the one we are going to use. Let's copy this. Inside the fetch function, I will open up a set of backticks and paste this inside. Let's delete this dash at the end. And for the endpoint, I will use $sign and curly braces to put this I variable inside. And that is basically going to represent the ID of the Pokemons that we are going to fetch. And because this I variable is set to 1, and we are going to increase it unless it reaches to 12, that means we are going to be using this fetch function 12 times. Next, we are going to put this response into a variable named data. And we are going to convert it to JSON. So now we have the data. We need to push these objects that are coming from this API inside this empty array. So we will use the push method on this array. Let's open up a set of curly braces because we are going to be pushing objects inside. So let's create some properties for this object. ID is going to be the ID that is coming from this API. So data.id. Name is going to be data.name. And also we are going to be displaying the image coming from this API as well. And as far as I understand from the documents of the API, this is the way to do it. So this is the way to access the image coming from this API. So we are done fetching the data, and only thing left is right outside this for loop, we are going to use the setPokemon setter function, which is responsible for updating this current state. And currently this Pokemon array is empty. And as I mentioned a second ago, we created this temporary array to temporarily store this data coming from this API. And now using the setPokemon function, we are going to take this list and we are going to update this actual array that we are going to use. And in this way, we basically update this original array that we are going to use. So now that we fetch the data, we need to display it as soon as the website opens. And for that, we are going to use useEffect. So useEffect is going to take two arguments, the function, and when this function is going to be executed. So in this case, the function that we are going to execute is fetch Pokemon, and we want it to be executed as soon as the website opens. And because of that, I will put an empty array as the second argument. That means execute this function as soon as the component renders. So the next function that we are going to create is called shuffle array. And this is basically the whole point of the game. We need to change the positions of the objects inside of the array because this is a memory game. Each time you click on a card, all the cards are going to be changing their positions so you can remember which one you clicked and which one you not. And using this shuffle array function, we are going to basically shuffle the items inside the array. So this function is going to take the array as the argument, and inside the function block, we are going to return the existing array. So if you don't know what it is, this is called the spread operator, and this basically creates a copy of the existing array without modifying or mutating the original one. In this case, we don't want to change anything with the original array, so we create a copy of it, and we will sort it using math.random minus 0.5. So each time you click on a card, we will call this function. We will take the current array and we are going to sort it by this random number that we create using math.random. And the minus 0.5 is just to create a random number for each execution of this function. And the final function that we are going to create is called handleClick. And it is going to take the ID of the card you clicked as the argument. So inside this function, we are going to basically define the whole logic of the game, and we are going to do it by using if statements. The first case is what happens if you click on the same card twice. So we will take the clicked Pokemon array, and if you don't remember what this does, this state variable is responsible for keeping track of the cards you clicked on, and if we have this ID you clicked on inside this array, that means you lose the game. So we will set everything to 0, set score to 0, and we are going to show you a alert, game over. And if you don't click on the same card twice, that means the game is continuing. And when the game continues, we need to keep track of the cards that you clicked on, and we also need to increase the score. So set clicked Pokemon is going to have the current cards that you clicked on. And also we are going to add the ID that you clicked. We will increase the score by 1. And also we need to update the best score. So if there is a new best score, to be able to update it, we will use math.max function, and we are going to compare the best score and the score plus 1. So let's say the best score is currently 5 and the current score is reached to 6, and this function math.max is basically going to compare these two numbers, and it is going to return the biggest one. And I just realized I forget a arrow in here. And also we will define another if case in case you win the game. And winning the game means score plus 1 is equal to 12. So if you click on 12 different cards, that means you win the game. So we will create this alert that says you have won. And we will reset everything back to empty. And we will set the score to 0. And outside this if case, each time you click on a card, we are going to use the shuffle array function to change the position of the cards. So now that we are done with the game's logic, we can display the fetched data inside this div. Let's open up a set of curly braces, and over the Pokemon array, we will use the map function, and for the each Pokemon, we are going to create this div. It is going to have a key of p.id. When you use the map function, you need to give keys to each element that you create, because React wants to uniquely identify each element you create. Inside this div, we are going to be displaying the image coming from the API, and right under the image, we are going to be displaying the name of the Pokemon. Let's give this card a background of white and rounded corners, a drop shadow, padding of 2, and for the smaller screens, padding is going to be 4. Cursor is going to be pointer, indicating that this is something clickable. And when you click on the card, we are going to scale it up just a little bit. And let's create a transition for the transform. And for the card, we are going to create a onClick event handler. And inside, we are going to be calling the handleClick function. And it is going to take the card's ID. Let's also style this image. Let's give it a width of 16 and height of 16. For the smaller screens, the width is going to be 24 and height is going to be 24. For the medium screens, it is going to be 32. And margin right and left is going to be auto. For the paragraph, let's center the text. Margin top 1. For the smaller screens, margin top 2. Text is going to be small. And for the smaller screens, text is going to be base. Also, inside this paragraphs, we are going to be displaying the score and best score. So currently, there are some small errors inside the code. Let's fix them together. The first one is the endpoint for this API. We need to add Pokemon dash. And also, inside this map function, I've made a mistake by using curly braces. This is going to be parentheses. And also for the medium screens, the cards are going to have the height of 32. And now everything is fixed. Before we finish, let's do a quick recap of everything we did. First, we have created 4 state variables. This Pokemon array is responsible for basically storing the data we fetch, and setPokemon function is responsible for updating this current Pokemon array. The second one is responsible for keeping track of the cards you clicked on, and using the setter function, we keep adding new clicked cards to this current array. So if you keep clicking on different cards, we keep storing the current data, and if you click on the same card twice and lose the game, we reset this array. And these two are pretty simple. This one is responsible for keeping track of the current score, and this is for keeping track of the best score. So if you exceed the current best score, we update it using this set best score function. Next, we have this fetch Pokemon function. Inside we have this empty array, and using a for loop for 12 times, we fetch 12 different Pokemons depending by their IDs, because the I variable is 1 at the beginning, and we keep running this loop until it reaches 12. So we fetch Pokemon 1, Pokemon 2, and so on. After we fetch the data, we store it inside this const data and convert it to a JSON object. After that, we push it inside this temporary array, and we also give it some properties such as ID, name, and image. After that, we use the setter function, setPokemon, to update this current empty array with the data that we fetched. Next, we use useEffectHook to execute this function as soon as the website is loaded. We use the shuffle array function. Each time you click on a card, we sort the current array by using math.random, and the handleClick function is basically have the whole logic of the game inside. It takes the ID of the card you clicked on, and using some if statements, we check if you click on the same card twice. If you did, we reset everything and alert you that the game is over. Else, that means you keep playing the game. So we keep track of the cards that you clicked on, and we add the new one to the existing array of clicked Pokemons. We increase your score by 1, and we compare your current score with the best score. In case if you exceed it, we return the new best score. And if you win the game, that means you reach the score of 12. We alert you that you have won the game. And then we reset the clicked Pokemons and we set the score back to 0. Outside all of this, each time you call this function, we shuffle the array of Pokemons. Inside this paragraph, we display the current score, the best score, and using a map function over the Pokemon array, we display the fetched data of Pokemons and names as this card. And every time you click on this card, we call this handleClick function by using onClick event handler, and we give this handleClick of this card's ID, and this is how the game's logic work. So let's click on one Pokemon. As you can see, we have scored 1 point, and now the current best score is 1. Let's click on a different one and another one. And as you can see, I clicked on the same one twice and the game is over. My best score is 5. Let's keep clicking. And I click on the same card twice again. Looks like everything is working fine. So this is how we can create this Pokemon memory game using React and Tailwind. I hope you guys had fun and enjoyed it. Thank you for your time, and I will see you next time.